Hello everyone, welcome to the channel Research with KB. I am Kasinath Boral and I am also a learner like you. Today we are going to discuss a very important and commonly misunderstood topic. The topic is the difference between correlation and regression. Many students, researchers and beginners often become confused between these two concepts because they are closely related. So in this video, we will clearly understand the meaning and differences between correlation and regression with example in a very simple way. Let us first understand the meaning of correlation. Correlation is a statistical technique that measures the strength and direction of the relationship between variables. It tells us whether variables move together and how strongly they are associated. Therefore, correlations refer to the connection or association between variables. It answers the question, are these variables related? For example, consider two variables. One is time spent studying per week measured in hours, and another one is achievement score, that is marks. In this case, correlation helps answer the question, do students who study more tend to obtain higher marks? On the other hand, regression is a statistical technique used to predict or estimate the value of one variable based on another variable. It helps researchers understand how changes in one variable are associated with changes in another variables and enable forecasting. Therefore, we can simply remember regression equals to prediction or forecast. Regression answers the question, can I predict one variable from another? Is the same example, regression use known study hours to predict a student's expected examination score. Now let us look at some important difference between these two techniques. Correlation measures the degree of relationship between variables, whereas regression predicts the value of one variable from another. Correlation only indicates association and not implies causation. Regression, however, models how a predicted variable is related to an outcome variable. In correlation, there is no distinction between variables. Both variables are treated equally. However, in regression, variables are classified into independent and dependent variables. In correlation, the relationship symmetrical. This means that the correlation between x variable and y variable is exactly the same as the correlation between y variable and x variable. In regression, the relationship is asymmetrical. Predicting y variable from x is mathematically different from predicting x variable from y variable. The numerical value of the correlation coefficient is always between -1 and +1. A value close to +1 indicates a strong positive correlation. A value close to -1 indicates a strong negative correlation. A value close to 0 indicates no linear relationship. We will discuss how to calculate the correlation coefficient in one upcoming video. On the other hand, regression coefficients are not restricted between -1 and +1. They can take any numerical value. In regression, a mathematical equation is used to model the relationship between variables. The most common form is the simple linear regression equation is y equals to b0 plus b1x, where b0 is intercept and b1 is regression coefficient. This equation represents a straight line that can be used to predict outcome and understand relationship. We will discuss regression analysis in details in our upcoming video. Now let us understand this concept using a real research context. Suppose a researcher collects data from a sample of 200 students and studies two variables. One is time spent studying per week measured in hours, and another one is mathematics achievement score, that is marks. How can this data be analyzed? Let us apply both correlation and regression. Suppose the researcher applies Pearson correlation and obtains a correlation coefficient of 0.78. This indicates a strong positive relationship between study hours and mathematics achievement score. Therefore, we can conclude that students who study more generally tend to obtain higher mathematics scores. This correlation analysis helps us understand that a strong relationship exists between the two variables. Now, let us apply regression to the same variables. Suppose study hour per week is an independent variable and mathematics achievement score is our dependent variable. After performing regression analysis, the researcher obtained the following equation. Mathematics score equals to 25 plus 4.5 into study hours. Here 25 is the intercept and 4.5 is the regression coefficient. Suppose a student studies 10 hours per week, then score equals to 25 plus 4.5 into 10 equals to 70. Therefore, the predicted mathematics score is 70 marks. Thus, regression enables the researcher to forecast future score based on a known value of study. Remember the simple statement: correlation finds relationship, regression use those relationships for prediction. Thank you very much for watching this video. I hope the difference between correlation and regression is now completely clear to you. If you still have any doubts or questions, feel free to write them in the comment section. I will also provide one MCQ based on today's topic in the pinned comment. Please try to answer it. In our next video, we will come again with another interesting concept related to research methodology or academic writing. Till then, keep learning, keep growing, and enjoy every moment of life. Thank you.